Okay, hey, what's up? It's your old pal, Mr. Cook. We're going to go through the college math chapter 2 test review. So it looks like it's 6 pages. We'll probably do 1 page per video. And yeah, let's get started. So determine whether each is a well-defined or not well-defined set. Well-defined set means that it's going to be like you're going to be able to figure out what it is from the description. A not well-defined set means that you can't figure out what it means, or that it's subjective based off of the description. So, like for example, number one, the number of teams in the NBA. Well, currently there are 32 teams in the NBA, so you just say 32. There are 32 teams. You probably list them off too. You can list them off if you need to, right? Because that's the description, number of teams. So this is going to be well defined. Since you know exactly what we're talking about here, you just need a list of the teams that are in the NBA. The second question says the most interesting historical figures in the world. Well, most interesting is subjective. Your opinion on who the most interesting historical figure might be different from mine. So my set might be different from yours, and therefore it's not well defined. Like there's no argument which teams are NBA teams. But there would be an argument as to who is interesting, in terms of historical figures. Okay, now the test that you guys are going to see for chapter 2 is going to be multiple choice. So one of the options would be well-defined, one of them would be not well-defined. So you just select defined for the right one, not well-defined for the other one. Determine whether each is finite or infinite or finite. So this again would be multiple choice, one or the other. And finite means that it has a distinct end to it. Infinite just means that it keeps going on and on and on forever. You can actually tell that just the way that it's written up. In number 3, we have the numbers 1 all the way to 20, but this one ends. So since it ends, that means that this is going to be finite. And then notice that this one just keeps going on and on and on forever, like there's no end to it. So since there's no end to it, it just keeps going ... There's nothing after the ... dots. That means that this one is going to be infinite. So those ones should be pretty easy. You just got to know the vocabulary for them. Rewrite each of these in roster form. What roster form means is that you just list off, exactly what the set looks like. So you list off every element in the set or every number or thing that's in that set. And you just make a list of them. That's it. So roster form means list everything, or list every what we call element in it. Okay. Now every element means every member of the set or every thing in the set. So number 5 says the set of natural numbers. So natural numbers are the ones that you can count: 1, 2, 3, 4, 5, 6, 7. So the numbers that are greater than 2 and less than or equal to 16. So, all right. So obviously there are two numbers here, 2 and 16. So I'm just going to list off the natural numbers, the counting numbers that go from 2 to 16. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. But if I listed off all of these, right, okay, this is roster form so far, but there's one thing that you got to check when they're talking about less thans and greater thans and all that stuff, okay? And that's the following. All right, so here's our little list. But notice that it says the natural numbers that are greater than 2. So the very first number that I start with, 2, does that include 2 or not? Well, it says that the number has to be strictly greater than 2. So that means that actually it does not include 2. So 2 should be left off of there. Now let's check the other endpoint, 16. So this one says that the numbers are less than, which is, less than means that it's below 16, or equal to. So that means that since it says equal to, it would include 16. So we're going to leave that one in there, okay? And that's our set in roster form. We just list off all the numbers that it's talking about. So for number 6, this one says x, such that x is in the natural numbers, and then also it's less than 9 specifically. So the counting numbers start at at 1, the natural numbers. So we have to start at 1 and then go all the way up to 9. So 2, 3, 4, 5, 6, 7, 8, and 9. Then we got to check the last number. Okay, so the first number, it definitely is going to be there because it's the very first natural number, 1. But then this one says strictly less than 9. So we're actually going to leave 9 off of there like that because it doesn't say less than or equal to 9. If it did say that, if it said less than or equal to 9, then I would also include 9. But it doesn't say that or equal to part, so I'm going to leave it off. There we go. So that's that one in roster form. Next one says the b values for x such that 3x plus 1 is equal to 10. So that means that it's any x value that solves this equation. So if you just solve it out real quick, using your algebra skills. So first thing we would do is subtract 1 from both sides of the equal sign. And then that gives us, let's see, -1 plus 1 gives us just a 3x all by itself equals, and then we have 10 minus 1, which is going to be 9. And then we solve for x. So we divide both sides by 3. And we get x is equal to 9 over 3, which is 3. So since there's only one answer to this, then that means that our roster is comprised of only one number. That's the number 3. We put the little squiggly brackets around it. Okay, so that's the first 7 problems. Now let's wrap up the first page. The next thing says to express each in set builder notation. So what happens is that you're given a set that is in roster form, and then you need to rewrite it so that it's like this, kind of like that, okay, written up in set builder notation, because that's what that says, set builder notation. So this is gonna be pretty easy. We're just like writing it the same way. You can actually even use the previous problems in 6 and 7 to write it up, and number 10 is helpful for number 5. So here's what we're going to do. Ready? We're going to say that we're going to do a little squiggly bracket, just like what we have here on this example right there, the squiggly bracket, and then an X, and then a little line right there. Okay, and then what we're going to do is, recognize what this is. It's numbers 1, 2, 3, 4, and 5. So these are going to be natural numbers. So we're going to write up something like this. So it'll be X. The X number that we're talking about is in the natural numbers. So we can just write up the natural numbers, or we can just write a capital N. And then the numbers go from 1 to 5. So we can write that a couple of different ways. So we can say and less than. Right. So we could say, X is in the natural numbers. And then we can also say that X is less than 6 and greater than 0 or something like that. So the natural numbers that are between 0 and 6. Or we can write it out in words as well. So X is less than, it's 5. So that means it would be less than 6, right? And greater than 0, okay? Because it's like more than 0. That would put us at 1. So you can write it up either way, and that would be the answer expressed in roster form. In set builder notation. Okay, and then we've got these numbers. So they go from 14 all the way up to 20. So we can do the exact same thing. Just because they're written up like in different orientation, going from greatest to least instead of number 8, least to greatest, we can just do it the exact same way. It's just numbers that go from 14, 15, 16, 17, 18, 19, and 20. So 14 to 20. So we can literally like write the exact same kind of thing, X, and then these are all natural numbers. So X is in the natural numbers. And then we can say that X is more than 13 or greater than 13 and less than 21 or less than or equal to 20. You can, as long as it says all the numbers that are between 20 and 14. I bet you could even write it out in that form. X is a natural number between, and including 14 and 20. You can write it up like that and it'd probably be fine as well. Okay, last one. So number 10, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Those are the days of the week. So that means that this set, we just started off the same way, X, and X is a day of all days of the weeks or something like that. Is all of the days of the week. Or you could say like it's one of the days of the week. That would probably be more grammatically correct because it's, all the different days. Okay, so that's different ways that you can write it up in roster form. There's like a lot of freedom in how you write the second part here. So just be aware of that. If push comes to shove, write down, what you're looking for. But again, remember that this is going to be multiple choice. So you'll be able to tell like from the options what your answer should look like. So if you can like do these ones, number 5 and 6 and 7, just kind of go backwards and say like, okay, so from these different answers in set build notation, how do I get like these results? That's like another way to look at it and another way that you can get those answers. Okay, so that's the end of the first page. And then we'll go on to the next page in the next video. All right, hope you found this one helpful. If you need help, go find your math teacher. They're probably available in the morning or after school. I'm Mr. Cook. I'll be on campus before school, after school. So if you need my help, come and find me and I'll help you out. All right, thanks for watching the video, and I hope to see you in the next one. All right, bye-bye.